Okay, got it. So I got a yes from participants. So we'll get rolling over here. First and foremost, thank you for joining this session. It is literally midnight in India, in Bangalore, from where I'm speaking. Uh, Give me 1 second. I'll start sharing my screen. Or is it, I think, already shared on Zoom? Yeah, I think it says new share, which means you are already screen sharing. So my session is around this open source framework, which I had built for testing and automating Salesforce. So let me get rolling with the slides. Okay. Um, so the session's title is TestZeus, Automate the Lightning and Thunder of Salesforce Testing. Okay. Quick word about me. I'm the Associate Vice President for Innovation at Provad. My handles, email, credentials, Twitter, LinkedIn locations are mentioned on the slide. So we'll not waste a lot of time over here. But first, a quick show of hands. So how many of you have worked on a SaaS application? So this could be Salesforce, this could be Workday, Oracle, ServiceNow. Okay, so I see one hand raised. Anyone else who has worked on these applications or any other SaaS application, and specifically from the angle of testing and automating scenarios for it? Okay. So then you know the pain. Okay, so I saw a few more hands coming up. So basically, with SaaS applications, my experience has been very less and not very detailed, so to say. This is around 2.5, 3 years back when I joined my last corporation. They, my boss asked me to test and automate a few scenarios on Salesforce. So what happened is that that was my first encounter with Salesforce, which is a SaaS CRM application. And basically, before that, I had done testing and automation for a few other applications built on full stack, mean MERN stack kind of web applications. But this was the first encounter, so to say, with a SaaS application, and that too specifically Salesforce. We tested a few scenarios, we automated a bunch of them, and then that story actually unfolds. I'll come to that in a minute. Okay. So on the next slide, what I'm showing is basically there's this small screen on the left-hand side. It says account created on. It's an account detail page for anybody who has seen Salesforce UI. This would be pretty regular, mundane stuff. And if you've automated Salesforce test cases, you would even be aware of the bottom section of the screenshot. Okay. So what I'm trying to display over here is that what looks very calm on the surface as the UI, right? Very few elements, very minimalistic kind of UX language has actually a lot going on beneath the surface. So what happens is that that simple UI is actually rendered by a plethora of web elements, deeply nested DOM. Salesforce also utilizes Shadow DOM in a lot of places. Plus, in addition to that, there are other challenges with automating SaaS applications, and in this specific case, Salesforce. So Salesforce releases their platform updates thrice a year, summer, spring, and winter. And whenever they do that, they tend to change a lot of UI elements. Okay. Other SaaS applications like ServiceNow and Oracle also follow similar patterns. So basically, if we do a left versus right kind of comparison, if you are working on in-house web applications, the DOM or the UI generally changes when there's a feature request, right? The developers then build it, you know what is coming through, and then you test and automate the corresponding scenarios. But with SaaS applications like Salesforce, there is this external party as well, the SaaS vendor or Salesforce in this case. Not only is the in-house development team, Scrum team making changes to the platform or to the application built on top of the SaaS platform, the SaaS platform itself undergoes maintenance and updates and upgrades on a regular cycle. Think of it as the new iOS version coming once a year. But in this case, it is thrice a year and then tends to break a lot of things from the test automation perspective. Okay. So as an example, we have this all drop files button for which I'm displaying the DOM element, which is span lightning. The XPath or the CSS could actually change as part of one of those updates. What this means, this specifically means that for the test automation teams, they have to continuously chase these releases, keep on making changes. And this ties back to the story that I was telling earlier. So what I learned the hard way was that you can have the best test automation framework built in-house by you and the team. You could be building best of the breed handcrafted XPath locators, but there's still a very high probability that those things might break just because Salesforce did a release and decided that they needed to change how the all drop files button or the new button or submit button or a pick list or drop down is rendered on the UI. So that's around the pain of doing test automation for such SaaS platforms. So, and that's where TestZeus comes in. So basically, when we met this challenge of regularly updated UIs by the SaaS platform, Salesforce, what we thought of was, could we attack this problem separately or differently than the standard approach, right? The standard approach being, okay, here's the web UI. Here is how the submit button works. Here is how the new button works. Let's try to, write the XPath for it. And then let's try to maintain it. But interestingly, platforms like Salesforce do provide APIs via the platform for rendering that UI. Okay. And rather than going through the front door of directly trying to attack the DOM, writing XPath, CSS locators for the web elements for our Selenium test cases, we kind of found the backdoor entry. So we'll just look into that in a minute over here. Okay. So this is the slide around how UI is rendered for Salesforce. Okay. So think of it as the layers on a hamburger. Okay. So there's the bottom layer, that's the core platform and shared services. So you can think of it as an entire application, right? So there's this backend, the middleware, and the front end. Salesforce, interestingly, has this core platform, on top of which it has the application layer, which drives this one pipe, if I'm allowed to say that, called the UI API, User Interface API, which drives the Lightning data services, and then which drives the base components and the experience components. Okay. So if we just remember the slides which I had shown a minute back, that UI where we had the account created on and first name, last name, and then the upload files button, that actually is being driven by these layers. And what UI API does is exactly as the name suggests. It takes the values from the backend and places them, plots them on the front end, right? And this UI API is the path or the backdoor that I was referring to earlier, that rather than attacking the DOM from the front end and trying to locate those web elements, can we somehow utilize the response from the UI API from the Salesforce platform itself to decipher, decrypt, and understand where are the web elements going to appear on the UI? Okay, so we'll look at that in a minute over here. So using that UI API, we build the auto-locator strategy in TestZeus. So on the left-hand side of the screen, we have a small detail page, right? It has the account owner, account name, phone number, other fields. And then that same bit is exposed by the UI API. It's a standard API which returns the JSON response. I was recently made aware of the fact that they also have a GraphQL endpoint. But basically, the front end can actually be requested by the UI API. It comes back as a very nicely formatted JSON. Now, this JSON brings up these three very key components for building the auto-locator strategy or the web elements for our Selenium test cases. Okay. So one is, what kind of element is it? Is it a text box? Is it a pick list or drop down, a date, so on and so forth, right? So using that value, we can actually understand the kind of action that we can take with it. Okay, so TestZeus as a framework understands is if it's a text field, you can actually fill values in that form. Two, the second bit is that it tells you that this web element is coming up on the first column, first row, right? So think of it as a graph system. Okay, so there are questions coming in. Thank you, Viju, for that question. I will answer them all one by one at the end of the session, if that's okay with you. Back to the response from the UI API. So basically, the part which I was trying to explain is that the UI API also tells you that, first section has this web element on this row, on this column. So example, account owner is actually column 1, row 1. Account name over here is column 1, row 2, so on and so forth. So rather than trying to write an XPath, right, driver.find element by blah, blah, XPath, and then we say contains text or text equal to account owner and dev slash something, we can run a for loop. It's as simple as that. Get all the locations and all the web elements in one shot and then interact with them, right? The UI API also tells you which fields are mandatory and some more metadata related information. Okay, so this forms the base for the auto-locators. This is how TestZeus understands this web element is standing here. Let me interact with this in this fashion. This text field is coming up in the first column, first row. Since it's a text field, we can enter text over here. Okay. So using this strategy, it not only brings down the test automation time or creation time, because the web element locators are pretty much borrowed from the UI API. It also brings down the maintenance time, because we are using the UI API, which is provided by Salesforce. If there are changes, let's say account owner becomes the second web element and account name becomes the first, we get that value at runtime, and then we can correspondingly interact with it on the fly, build that XPath on the fly, rather than having to change the XPath because it has broken or the location has changed. Okay, so this is one core aspect of TestZeus, which helps in building some of these locators on the fly and saves not only the creation time for test automation, but maintenance as well. So this is one standard API from Salesforce, which is being used in TestZeus. The other one is EPT. Now, generally, with test automation, in my experience, there are these two Achilles heels for any framework. One was the web elements. Web elements keep on changing, therefore the tests keep on breaking, right? So whenever we say flaky tests, there are generally these two elements to the flakiness of test automation scripts. One was the web elements, which we just saw, and we also saw the theoretical solution on how to solve it. Second is the wait times. Has the element loaded on the screen? Has the page fully loaded or not, right? So in our experience, we also found that Salesforce provides this second API, or the concept of EPT, experienced page load time. So there's this small box screenshot from the web app. And if you look closely, it has this green box which says 1.33 seconds. So that number is generally not made available or not made visible to the user. But if we pass certain arguments as part of the URL or as part of the request that we make to the backend, we get that value in the console and sometimes in the UI if we want to make it visible in the UI. So if Salesforce themselves is telling us that the page took 1.33 seconds, can we actually use this value to wait exactly for 1.34 seconds and then interact with that page, rather than write thread.sleep throughout our test cases to wait for something to appear? So this is the second core concept for auto waits, which we have utilized in TestZeus. Using this, the test case automatically waits, as the name suggests, for the page to load or the elements to render, rather than using thread.sleeps or making the test cases slow and brittle. Okay. This is a quick high-level framework diagram. The numbering 1, 2, 3, 4 is the sequence of execution. So we have the POM XML, which triggers test.ng, which has the repository of test cases to be executed, which triggers these individual test classes. The test classes themselves are abstracted from base test. Specifically, EPT or concepts like auto-locators are coming from SF page base. The entire framework is open sourced under GPL v3 license. And to Biju's question earlier, it's hosted on GitHub. So it's free, open source, FOSS, GPL v3. It's built on top of Selenium. It's not part of Selenium. It's a wrapper on top of Selenium, specifically built for Salesforce and to ease out the pains for automating test cases in the Salesforce ecosystem. Okay. I hope that answers that question. But we will look at each one of these boxes in a little bit more detail in a minute over here. Okay, so then we have the demo. We'll take a pause. Any questions? We have a small, lovely group over here. We can even take questions in the middle rather than waiting till the end. Or, please feel free to post questions in the chat if there's anything which I can help answer right away. Or I'll just skip the presentation mode and we'll go look at the demo together. Okay, so I've cloned a copy from GitHub. I'm presenting Eclipse. And as you can see, the test case which is open over here is the account creation via UI. It's all in Java. We are using the Java version of Selenium. And we also have, or TestZeus also has the capability to automate test cases via the APIs. So, if you go and clone the repo, or if you look at the code on GitHub, you'll also find a test case named as account creation via the API. So both of those aspects are available. I have a question in the chat. Okay, yeah. So this is what we are looking at. We've tried to add as many comments to the code so it's self-serving as much as we could. So what's happening in this test case is actually very simple. If you go by the comments, it's actually a pretty small test case. We're navigating to the login page for Salesforce. And then there's this concept of the app launcher in Salesforce. We are specifically opening accounts as this object. We can open any other object as well. Clicking on new. Once we click on new, a lot of magic happens on line number 30, where we are parsing the response from the UI API. We have to pass the record ID as a template for which we get the response back. Then we can actually create an account using the values passed as test data. If we look very closely, let's look at line number 38. It says account list page dot form value filler. This actually hints at page object design pattern. So we are utilizing that for designing some of the pages that we have on Salesforce. And the form value filler is the method which actually utilizes the responses from SF UI API or Salesforce's UI API and fills in the value. The test automation team or the tester doesn't have to actually write the XPath or CSS locators or web elements explicitly when trying to interact with SIG code as an example over here, or let's say with account name as an example over here. As long as they know the name of the label or the field or the web element that they're trying to interact with, they can pass on that name. UI API response is matched with that. And then TestZeus makes the instructions on your behalf because it's trying to create the XPath on the fly. So once it fills in the form, it clicks save. There's also this small placeholder test at the bottom, the second one, because we are getting the list of required fields also on the UI. So we try to verify that as well, that, okay, out of these 50 fields on the form, these 30 are required or not. We're just validating for account or account data as an example, but the same thing can be done for each of the fields. on the UI. Okay. So as I had shown the framework earlier, the same test can be triggered via POM, via TestNG. So we'll try to trigger it as a TestNG test and see how it goes. Okay, there's some logs coming up. Okay, I have two screens. So it opened up the browser on the second screen. So basically, this is the Salesforce login page for my developer instance. The framework puts in the values of user ID and password. Interestingly, when it is doing these navigations, it is utilizing the concept of experience page load times, as I had demonstrated earlier. So it's exactly waiting for the time that it needs to. There are very few explicitly mentioned waits in the framework. Once it goes on to the list page, clicks on the new button, as per the test case, it has this form. We are only filling a few values, but all of these values come back as a response from the UI API. So we can actually interact with each one of them. So given the limited time at hand, we are just interacting with a very few to quickly create that account. Once that account is created, it can be validated on the UI. We can also validate it via the API that actually that record got created on the backend or not. Okay. So the whole test comprising of two atomic units, two small test cases ran very quickly. Now there is this one interesting thing which I want to show over here. So yeah. So we get a very long JSON response from the UI API, but some pieces are being printed as part of the console logs over here. And as you can see, it gets a list of all the labels and their types. So for example, SIG code is a string, and there are some pick list values and Booleans and phone numbers and so on and so forth. So that is how TestZeus basically does these promised things. One, understand the web element. Where is it exactly or actually? Column one, row one, right? Builds that XPath on the fly, interacts with it. Two, since it's a string or a pick list or a Boolean, it also knows that it needs to enter true, false only as the values, or maybe a date, or this drop-down value or the string value. So it brings down this creation time. And since it knows the elements coming on the UI, it also brings down the maintenance time in the future. In addition to that, using EPT, experience page load times, it lowers the flakiness of the automation test case. Okay. So going back to our slides, that was a quick demo. So personal experience and other footnotes. So as I mentioned, TestZeus basically helps us not only accelerate the test automation efforts, it also helps us in bringing down the maintenance, both for the web elements and the waiting times. TestZeus is an open source test automation framework built as a wrapper on top of Selenium. It's a proof of work. It utilizes Salesforce's provided standard APIs, the UI API or EPT. Target users for TestZeus are technically strong engineering teams, and it's a GPL v3 open source project, and we are open for contributions. So what's the road ahead? There's a small poem on the left-hand side. Life does not come with a compass, and a few more lines which you can go through. But basically, for TestZeus, it is evolving based on our usage, our own experience as testers, automators, builders, engineers for the Salesforce platform. So it will continue evolving in the years to come. And there are links for resources and support on the right-hand side. This is not like a weekend project, which is one and done. There's this very healthy Salesforce community for test automation trailblazers. That's the hyperlink for that. Salesforce also provides these very interactive courses and content for learning about the platform. That's Trailhead. We have the Selenium community on Slack. And last but not the least, the TestZeus GitHub repo can be found at testzeus.com. That's pretty much about it. Thank you for the session and tuning in. We'll quickly go over to the questions. Okay, are there assertions in your test case code, or are those in the shared common code. So basically, in the framework, we have two test cases where we have written the assertions. We can write many more as we build the test cases, as you build the test cases. So it's not very opinionated in that way, so to say. And therefore, a lot of assertions are not there in the code itself. You can build them as you build the test cases. Okay. So I think I answered Viju's question earlier. Is TestZeus part of Selenium? No, it's actually a wrapper on top of Selenium. It's a GPL v3 open source licensed project. It's not a part of Selenium in a simple way. Okay, Viju has more questions. Is TestZeus a software tool or a GitHub type library? I would say a GitHub type library. It's more of a framework. So, and just to add on to that, you can actually use it in these two ways. One, if you're starting out fresh, if someone's starting out fresh, automating their test cases on Salesforce, they can fork the repo and start building test cases out of it, on top of it from scratch, because it has everything from Maven to TestNG to Selenium dependencies to Salesforce APIs, nuances, and everything inbuilt into that framework. So you can just clone or fork the repo and start building test cases on top of it. The other module, the other way of using it is it's also published as a Maven repository. If you already have a framework and want to interact with the Salesforce APIs or use some of these methods which I have displayed, you can import that Maven repository into your own framework and then start using the methods from there onwards. I hope that answers the question. Sure. Thank you.